3.3 talks about, they call it polynomial identities. It gives us the opportunity of different ways to multiply or factor special types of polynomials. Okay, so pretty much, technically on all of these, I'm going to kind of show you some shortcuts, some workarounds, but that doesn't necessarily mean you have to use them. Okay, so when they talk about polynomial identities, it's kind of looking at formulas in a way. You can use them, or you can go back to what you already know. Okay, so we have 4 polynomial identities here, and as you see, it's special polynomial identities can be used to multiply and factor polynomials. So a couple of these, well, this first one you already know. Okay, difference of squares, you're familiar with that, in that if something is a squared minus b squared, we can factor it into 2 parentheses where we take the square roots of the first and the last, and we use opposite signs. Okay, we could also use that to multiply back together. Okay, square of a sum. The idea, we did one yesterday that was a plus b quantity squared. And it took me a little convincing to get you guys to say, okay, we need to take the first piece and the second piece and FOIL them out, right? Well, you can still FOIL them out, or you can kind of use a shortcut here, and I'll go through that. And then the big thing that we are going to learn that definitely comes up later on in other pieces is sum and difference of cubes. And not so much how you multiply them, but we're going to talk about how we use a cubed minus b cubed and how we factor it. Okay, so those are the things we're looking at today. Depending on how timing goes, I don't think I'm going to get all the way through 3.3 today. It'll probably take tomorrow to finish it. But then on the back, we'll talk about, okay, how do we multiply something out if it's raised to the 6th power or something crazy like that. We'll look at some shortcuts there that you'll definitely want to use. So, as we look at A, use polynomial identities to multiply the expression. As I said, you can still do a shortcut, or you can still multiply them out normally, but this fits the form right here of one term plus another term quantity squared. So this fits the form of square of a sum. And so we can think of it, rather than foiling it out, if you are someone that you can become comfortable with this, you can think about filling in this formula. And so the idea, if I think of that as a plus b squared, well then when I multiply it out, it's going to be a squared plus 2ab plus b squared. Okay, so as I said, it's kind of a little bit of a shortcut. What would you say is in place of a? Not just 2, but the whole term. Okay, so the idea that every time we see an a in the answer, it's going to be 2x squared. What would you say is in place of b?
Y cubed.
That is the term y cubed. And so we can use those definitions right there. Every time we see an a, we're going to fill in 2x squared. Every time we see a b, we're going to fill in y cubed. So, a squared. What am I going to be squaring? We're going to be doing 2x squared, and then we're going to square that because it's taking a and squaring it. Plus 2ab. So that says I'm going to do 2 times a, which is 2x squared, times b, which is y cubed. And I'll clean this up in a moment. Plus b squared. So what do we have representing b? And that's not just y, but y cubed. So it's going to be y cubed quantity squared. And now we can clean this up. 2x squared quantity squared. What do we get when we square 2x squared? 4x what? Okay, that's why I didn't understand it. Okay, 4x to the 4th. Okay. And remember, here you're raising, when you do these powers, it's power times power. Plus 2 times 2x squared times y cubed is going to be 4 x squared y cubed and y cubed quantity squared. Y to the 6th. Okay? And that right there is your answer. Now, I don't know that I'll show this on everyone, but I think I will show it on this one, just kind of, if you're kind of hesitant. If you're not one, you're thinking, I'm not sure these identities are for me. What could you have done instead? I'm not sure I left myself enough room, but 2x squared plus y cubed times 2x squared plus y cubed. Could you just FOIL that out? If that is more your preference. And that's definitely an option. Okay? So I'll FOIL it with you real quick just for proof that it does work out. 2x squared times 2x squared is 4x to the 4th. 2x squared times y cubed is 2x squared y cubed. Insides, y cubed times 2x squared. Again, that's going to be 2x squared y cubed. And then lastly, y cubed times y cubed. Y to the 6th, because we're adding exponents. Does that match up there?
Yeah.
I mean, I have to add my like terms there, don't I? But it matches, okay? That is the same as 4x to the 4th plus 4x squared y cubed plus y to the 6th. Okay, so it matches. The identities are something that can help you. They can help you with shortcuts. They're not something you have to use. Okay? Okay, let's look at B. Which one is this of the form of? 3x squared plus 5y cubed times 3x squared minus 5y cubed.
Difference of squares.
Yeah, this is difference of squares, isn't it? This is a plus b times a minus b. Some of you guys probably already actually use this shortcut in a way, but the idea is a plus b times a minus b. Well, what's that supposed to equal? That's supposed to equal a squared minus b squared. Okay, well, what is our a here? Okay, in the position of a is 3x squared. What's in the position of b?
5y cubed.
And that is the 5y cubed, isn't it? Now, with that in mind, you can just take the shortcut. When you multiply this out, it's going to be a squared minus b squared. So a, which is 3x squared quantity squared, minus b squared, 5y cubed, quantity squared. Okay, well, what is 3x squared quantity squared? If you don't like that, just ask yourself, what is 3x squared times 3x squared?
6x, 9x.
9x to the 4th minus 5y cubed quantity squared, or 5y cubed times 5y cubed. 25y to the 6th. Now, I don't know, do I need to work this one out via FOIL?
No.
Okay.
Some of them are easier than others.
And I think this is an easy one. Because this is one where, and I know some of you already do this because you'll be like, the middle terms are going to cancel. Do I have to write them out? No, if you recognize that, oh, plus and minus with the same pieces, my middle terms are going to cancel out, you can do just this. Now, if this is not your style, Are you still going to get the same answer when you FOIL? You are. Okay. And feel free to FOIL along the way if you prefer. Okay. That was a little bit with multiplying. We're going to reverse it on the bottom part of the page, and we're going to talk about factoring. Okay. As we look at A, 9m to the 4th minus 25n to the 6th. Which one does this match up with up above? Is it difference of cubes? And we can narrow it down to two. It's either difference of squares or difference of cubes, yes? Here's the deal. 9m to the 4th and 25n to the 6th. Are they perfect squares or perfect cubes? And when I look at 9 and 25, I know that they are perfect squares. So that's why this is going to fit into the form of difference of squares. Now, with that in mind, okay, I'm going to kind of leave a gap here, so I'm going to go back in. That means this is going to be of the form a squared minus b squared, right? And if it's of that form, a squared minus b squared, if you look up above, it's going to factor into a plus b and a minus b. Now, in order to do this, what do I need to be able to figure out? I need to be able to figure out what a is and what b is. Thoughts on what a is?
9.
Let me ask a different question. What is a squared? A squared is 9m to the 4th, yes? So if a squared is 9m to the 4th, how do we find a? Not divide. Take the square root. Okay. The idea here that the square root of 9m to the 4th, well, the square root of 9 is 3. Remember to do the square root of m to the 4th. You're not actually square rooting 4, you're just taking that 2 and dividing it by 2. Okay, so the square root of m to the 4th is m to the 2nd. So that 3m to the 2nd is my a value. Okay, in other words, I could think about 9m to the 4th as being 3m squared quantity squared. Okay. What about b then?
Square root of 25 negative 1.
Just square root of 25 into the 6th. The minus is just part of the form of the problem. Okay, so don't ever throw that minus in there. It is going to cause grief there. Square root of 25 is 5. That's the easy part, right? Square root of n to the 6th
3.
is n to the 3rd. Because think about it. It's not, when it's an exponent, it's not taking the square root of the exponent. It's n to what power times itself is going to give me n to the 6th. And so the shortcut there is to take that exponent, and it's an index of 2, so divide by 2. So that's going to be n to the 3rd. That is your b value. Okay, so this can be thinking as 5 n to the 3rd quantity squared. Okay, so you're thinking square roots here. We've done some factoring with difference of squares this year, but I don't know that we've done them quite this bigger, the bigger values and the trickier exponents. Okay. Can you write out your answer?
Suppose.
If we're trying to factor this, it's supposed to be a plus b times a minus b. What's a plus b?
3n squared plus 5n cubed.
Are you guys with him?
Doesn't sound like it.
It doesn't. I agree. Okay. So a was the square root of 9m to the fourth. That was 3m squared. That goes in the first position. B is the square root of 25m to the sixth, which was 5m to the third. That goes in the second position. That's a plus b. A minus b, well, that's going to be the same two pieces, but instead of a plus sign, we're going to have a minus sign. So 3m squared minus 5m to the third. And that's factored. I'm not thinking I have people convinced, though. Okay. You don't believe me? How do we check ourselves?
Foil it.
Can you foil it back together? Okay.
No.
I'm going to do more of a mental foil where I'm not going to necessarily write it down, but I do want to talk about it. If we first, 3m squared times 3m squared, that is 9m to the fourth. Okay. When you do your outsides, 3m squared times minus 5m cubed, well, that's going to be a minus 15m squared n cubed. What do my insides multiply to be? That's going to be a positive 15m squared n cubed. So that outsides and insides will cancel, and then your last is the minus 25 into the sixth. Okay? So with difference of squares, the shortcut is just take the square root of each piece, fill them into your parentheses, once with a plus, once with a minus. And this is just like if we had done, we factored x squared minus 25 this year, right? That's exactly what this is doing. X squared minus 25, factors into x plus 5 and x minus 5. Because x squared breaks into x and x. The square root of 25 is 5, and we use a plus and a minus to get that middle term to cancel. That's exactly what we're doing, but with trickier terms. Okay? I don't know, does seeing the easier one help a little bit? But we've done this. This is just a bigger scale version of it. Okay? B. It's a difference again, right? There's a subtraction. I say difference because subtraction in the middle, yes. Is this difference of squares or difference of cubes? Squares again. And here's the deal. 9 is a perfect square, yes. And then exponents. Exponents are perfect squares if they can divide by 2 as a square root. So that is difference of squares again. So that means, again, just like previously, I'm going to think a squared minus b squared, which means when I fill in my answer, a plus b times a minus b. The question is, can you come up with a and b?
Let's just say no.
You can. Have confidence.
We gotta do the square root of both of them.
Yeah. So if a squared, so m to the 8th. You've basically got to ask yourself, what is the square root of m to the 8th?
And the fourth.
M to the 4th. Take that exponent and divide it by, it's a square root, so divide it by 2. Okay, so that is my a value. So that means m to the 8th could be written as m to the 4th quantity squared. Okay. What is the square root of 9n to the 10th?
3n.
Okay, square root of 9 is 3, regular everyday number. Square root of n to the 10th, it's a square root of an exponent, divide square root, so divide the exponent by 2. 10 divided by 2 is 5. So 3n to the 5th is going to be my b value. Okay. Let's write it out. You found your a and b, right? Put them in your parentheses, once with a
Add addition sign.
addition sign and once with a
Subtract.
subtraction sign. So what do we have? M to the 4th plus 3 into the 5th and m to the 4th minus 3 into the 5th. Okay. It looks fancy. It's just a bigger, badder version of x squared minus 25 or x squared minus 9 or whatever we've done this year. Okay. C.
Can you divide 216 by 3?
Not divide by 3.
The square root cube.
Yeah. So x to the 3rd. Is that a perfect square?
No.
No. Is it a perfect cube?
Yeah.
Yeah. 216. Take a guess. Is it a perfect cube?
Yes.
It is. You can do cube roots on your calculator. That is something to make sure you figure out how. Okay, it's just a matter of where. Cube root of 216 is not dividing by 3. It's what number times itself again, yes? You know where to do cube roots on your calculator?
Sure.
Sure.
Yeah, pretty close.
There's, what is it? There's an x root. I'm trying to remember. Yeah, so on my calculator, above the square root, so if you're using one of the TI-30X2S's here, here's your square root, yes? Up above the caret is the x root. So if I want to do a cube root, that means I start off by typing a 3. Then I'm going to do second, and that button right there, right? Which is that right there. And that's going to take the cube root of whatever I type next.
Let's see here.
The cube root of 216 is
6.
6. Now, does that make sense? Yes, because 6 times 6 times 6 is 216. If you have a different calculator, if you have a scientific calculator, your calculator does cube roots. And I can help you figure out how. It's just a matter of, you know, if it's a little bit different or whatever. But these calculators do cube roots. Could you also just play around and figure out that it's 6?
Yep.
You can. Okay. So, with this in mind, that means this is a sum of cubes, yes? Sum of cubes. So this fits the form of a cubed plus b cubed. Okay, now, this is one, folks. I don't have a way to do this one other than use the formula. Okay? This one's kind of using a formula. You know, some of the stuff you can get away without knowing the formulas. This one, you're going to have to know how to use the formula. So a cubed plus b cubed, if you look up above, it's supposed to factor into a plus b times a squared minus ab plus b squared. Did I get that right? Brain's a little rusty there. Okay. What do you have to know to do this problem? A and b. That's all you have to know. Now, earlier on difference of squares, a and b were the square roots. Difference of cubes, a and b are going to be the cube roots. What is the cube root of x to the 3rd?
Plus.
X to the 1st. Okay, and your shortcut with exponents, guys, 3 divided by 3 is x to the 1st. Or in other words, just x. This is going to go in position of our a value, because this can be rewritten as x raised to the 3rd. We already did this. What is the cube root of 216? 6. That's going to go in place of our b value. Are you following? And this is how I know, right? Because I can rewrite this as something cubed plus something cubed. Those somethings are my a's and b's. Okay, ready to fill it in? A plus b. What's a plus b? What's a? X. What's b?
6.
So what's a plus b? No? X plus 6. Parentheses. Now we got to do the trinomial. A squared. Well, a is x, so x squared minus ab. What are my a and b? X times 6. Now, am I really going to write it as x times 6 for my final answer? No. Jump to your final answer if you want. Plus b squared. What's b? 6. And that's going to be 6 squared. Okay. Clean it up when you write your final answer. X plus 6 times x squared minus 6x plus 36. Okay. Difference of cubes, sum of cubes, those are the ones that are really new today. Those are the ones that we're going to have to work a little bit. Those are the ones that my kids in pre-calc and calc just have to know. They'll randomly throw in factoring, difference of cubes, and sum of cubes. So it is something to work to know. This is first introduction of it. So, okay, questions here.
No.
You should just
Okay.
do the last one and then be done.
We got to do D. Okay. Which form does D fit into? It's a difference. So I've got a 50-50 shot here. It's either difference of squares or difference of cubes.
Cubes.
Cubes?
Yeah.
Yeah. Okay. So because of the 9, because of the 27, can I do the square root of 27?
Okay.
No. It has a cube root, though. 343, is that a perfect square?
No.
No, but it is a perfect cube. Okay. So this is going to fit into the form a cubed minus b cubed, which is a minus b times a squared plus ab plus b squared. Okay? All you have to know are a and b. Do we have enough confidence yet to figure out a and b?
Yes.
Yeah? Okay, good. So in order to figure out a, I'm going to be doing the cube root of 27x to the 9th. Cube root of 27. 3, right? 3 times 3 is 9. Times 3 is 27. So cube root of 27 is 3. What's the cube root of x to the 9th? What do we do with the 9?
3.
Divide by 3. 9 divided by 3 is 3. So this is 3x to the 3rd. And this is going to be my a. And the idea is that if I rewrite this over here, 3x to the 3rd, if I raise it to the 3rd power, I get 27x to the 9th. Okay. Cube root of 343 y to the 6th. Did you ever figure it out? Remember, if I want to do a cube root, I can do 3, my x root button, and then 343. Cube root of 343 is 7. 7 y to the second, because you're taking 6 and dividing it by 3. So that's 7y to the second. That is your b value. 7y to the second, when I cube it, should work out there. Okay? Write your answer. A minus b. What's a? 3x cubed. Minus b. What's b? 7y squared. Okay? A squared. I'll come back and clean this up in a moment, but this is going to be 3x cubed quantity squared. Which, I'll go ahead and, what is that? Let's talk about it.
3x to the 6. 9.
X
6
to the 6.
9.
I'll take 9x to the 6 for the win, please. Because 3 squared is 9. Oh, because what did you guys do? I just realized it. You just squared the exponent, right? We're squaring the whole term, so square the 3 as well. Okay. Plus AB. So A is 3x cubed times B, which is 7y squared. What is 3x cubed times 7y squared? 21x cubed, y squared. Plus B squared. B is 7y squared, and then we are squaring it, yes? What is 7y squared quantity squared? 49y to the 4th. And out front, I didn't write it down yet, 3x cubed minus 7y squared. Okay.
Go ahead, save that.
Call it a day.
Please.
We're gonna start on it, and then
I
we're gonna
cannot stay
get
awake.
stopped.
Well, the position we're in is that I have 5 minutes, and explaining it and then actually working through A is going to be a little bit tricky. So if you look at, take a glance at A with me real quick.
Yep.
It's x plus y to the 6th. Officially, what does that mean if I'm multiplying it out by hand? X plus y times 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 x plus y.
Are we gonna draw these goofy triangles?
No, you're going to use a row of information from that triangle. Okay. No, that triangle is provided.
Okay.
That was just the best place. I was trying to find a place to put it.
I didn't know if we had to draw that one for that, for A
No.
and different.
Nope. So the triangle, this is part of binomial expansion or binomial theorem. We'll go through it tomorrow, go through those 3 examples, and you'll see. Like if you look at my answer for A, there's my answer for A.
Holy.
Okay. However, I'm not going to be foiling that a whole bunch of times. Okay. This triangle and using the idea of binomial expansion really makes it a little bit easier. Okay. So we'll talk about that tomorrow. 3.3 homework should be out there and available. You can do anything that is factoring or raising to the power of 2, right? Because those fall into this category here. I would save anything that has high powers or binomial theorem, binomial expansion for tomorrow. Okay?